So topic 3.14b is going to be on a different type of polar graph. Sorry, that's called a Limacon. So it's super fun to say. But a Limacon is going to be in the form R. There are two forms. Either R equals A plus B cosine of theta, or R equals A plus B sine of theta. And then just depending on if it's sine or cosine is going to depend on like which direction the Limacon is pointing, similar to with the circles and the roses that we talked about in the previous lesson. And so whenever we're doing the cosine Limacon and the b value is greater than 0, positive b value, the Limacon is going to kind of like be fatter on the going on the positive polar axis. And then if it's a negative b, it's going to be fatter on the negative side of the polar axis. All right, and then the Limacon is going to have intercepts at positive and negative versions of whatever A is. All right, for the sine Limacon, whenever that B value is positive, it's going to be sticking up more on the positive vertical axis. Negative is going to be sticking up more on the negative vertical axis. And again, A determines the intercepts. All right, and when anytime the absolute value of A is less than the absolute value of B, it creates this Limacon that's called an inner loop. Whenever the absolute value of A equals the absolute value of B, it creates a cardioid. And then finally, when the absolute value of A is greater than the absolute value of B, it is either called a dented Limacon or a clam. All right, and each one of these are going to have a maximum radius. That's going to be like the fat part from the origin or the pole. The max radius is going to be formed by taking the absolute value of A and adding the absolute value of B to it. All right, and then the clam, has a minimum radius, and the inner loop has a loop radius. And both of those are found by the absolute value of A minus the absolute value of B. Okay, so let's do some of these little graphs. On 1 through 3, we're going to identify the type of Limacon first, and then we're going to find the max radius for all types. We're going to find the min radius for the clams. We're going to find the loop radius for the inner loops, and then we're going to do a little basic sketch. All right, so this first one, we're looking at the absolute value of A and the absolute value of B. A is definitely larger, so this one is going to be a clam. All right, so all of these have a max radius that's found by ignoring signs and adding these two numbers together. Oh, I added wrong, sorry. All right, a clam has a minimum radius by taking those numbers, ignoring the signs, and subtracting them. Okay, and then we're also going to have some intercepts at A, positive and negative A. All right. And then since this is a sine clam, then it is always going to be kind of the vertical one. And whenever this is negative, it's going to be longer on the negative side. So it's going to kind of look like that. Hopefully we'll try to make it look like that. We'll see what happens. Okay, so I know we're going to be taller on the negative side of the vertical axis. So that's where I go 6 units. All right, and then my minimum is up 2. All right, and then I'm going to go over 4 in each direction. Okay, let's see if I can draw a clam that kind of hits all those points. It's a kind of a wobbly clam. That was really terrible, but that's okay. Okay, so this is the next one. So on the next one, I noticed that the absolute value of A and B are equal, and that's going to be a cardioid. It's going to kind of look like a heart. A cardioid is going to have a max radius by taking those values and ignoring the signs and adding them together. And we're also going to have a couple intercepts. Right, and then since this one has a cosine, it is going to be kind of like a horizontally shaped heart, I guess. And there's a positive here, so it's going to be longer on the positive side. And cardioids also go through the pole, or you might probably still think of it as the origin. So I'm going to go 4 to the right. I'm going to have my 2 little intercepts, up 2 and down 2. Okay. And then I'll make my heart. Let me try that. I'm really bad at drawing these with this Apple Pencil. Okay, and this last one, you guys notice that the first number is definitely smaller than the second, so this is going to be the inner loop. So inner loop, well, they all have a max radius by adding. The inner loop has what's called a loop radius by subtracting. And they all have these intercepts from A. All right, so this one is a sine Limacon, and so we're going to have a vertical Limacon, and since it's a positive here, it's going to go taller. So we'll have like a loop. Oh, hold on. All right, so we are gonna, from the pole, we're gonna go up 4. We're also gonna go up 2. All right, and then we are going to do our intercepts. All right. Oh, that's not right. All right, when we look on the next page, you can see what an inner loop is supposed to look like. All right, and so what we're going to do is pick out which formula or which expression is this function. So it is, you can see the inner loop. Oh, and all of these would have inner loop because the absolute value of A is less than the absolute value of B, so that's good. This one is vertically arranged, so it's definitely going to be a sign. This one is, so we can mark out C and we can mark out D. And then because this one is longer on the negative side of the vertical, then there's going to be a minus sign in between. All right, and then these last three are kind of reviewing all of the different polar functions. So we're going to identify these as circle, rows, or Limacons, and then we're going to do a rough sketch. All right, and so on this one, it is from the previous lesson because there's no addition or subtraction like there is for the Limacon. And because I have this number here, then it's definitely going to be a rows. And because that number there is an even number, we would double that to know the number of petals. And this number in the front is going to give us the length. And then because this is a sine rose, then I know the angle of the first petal is going to be at pi/4. And then we're going to do a very rough sketch. I'm going to try my best. Oh, terrible. All right, and then for 6, this is going to be a Limacon because I see that addition or that subtraction. More specifically, it's going to be a cardioid. All right, and so for these Limacons, we worry about the max radius. The max radius of this one is going to be 10. And I know since this one is sine, it's going to be vertically aligned. And then because it's negative, it's going to be tallest on the negative side of the vertical, so it's going to be something like that. That's a rough sketch, guys. This is going to be 10 down here. All right, and then this last one is going to be a circle. And I know this circle is going to have a diameter of 5. I know because it is a cosine circle, that is going to be on the right side. Well, for one, I know it's going to be either on the right or left of pi/2. Because it's a positive, we're going to be on the right of pi/2.